Hello, this is Mr. Collier, and today we're doing 3D distance formula, midpoint formula, and right angle trig. Okay, here are the formulas from the formula booklet. The 3D versions are in New Learning, and the 2D are in Prior Learning, but the same formula, just an extra variable z, right? So in 3D, we need three variables to represent a location. X, Y, and Z is usually the vertical axis here. If you're thinking in 3D, this could be like the ground, and this could be the height off the ground. But usually we have X, Y down here, and Z up here. But it could be oriented differently. Alright, so let's look at some examples. These examples are pretty simple. To get the distance between these points, you simply use the formula for 3D. So you just do root and subtract the x values. We get 5 minus 3 squared. And then the y value is 12 minus 0 squared. And then 10 minus negative 1. Be careful of that. That's a negative 1. And there's a negative in the formula, so it's minus negative 1 squared. So it's root 2 squared plus 12 squared plus 11 squared. And you can type that directly into your calculator, and it spits out about 16.4. And the midpoint formula, the same thing. You can just substitute these values in. And this time it's going to be 5 plus 3 divided by 2, the average of 5 and 3, and the average of the y values, and the average of the z values. So the midpoint between these 2 points in 3D is 4, 6, 4.5. Okay, let's look at a couple of examples here. This is a box. They give you, they give you that this is the origin over here, and they give you vertex A, which is right there. So you can figure out the coordinates of all the other ones. So so if you start the origin is 0, 0, 0. To get to R, you just go 2 in the x direction. Because A is at 2, 3, 4, that means it's 2 in the x direction, 3 in the y direction, 4 in the z direction. So R is 2 in the x direction, but still 0, 0. And then you got C. Point C is over here. To get from the origin to C, just move in the y direction. So the y value becomes 3, but the other two are still 0. And B is up here. To get to B, we need to go in the y direction and then in the z direction. So x is still 0. So we go in the y direction 3 and the z direction 4. And lastly Q is over there. To get to Q, we can go in the x direction and the z direction. So the y is 0, and the x is 2, and the z is 4. So those are all the coordinates of those points, which you can then use to solve the other problems. Find the maximum length of a garden tool that can fit in the storage box. That's this dashed line right here, the distance RB. So we can use the distance formula that we just saw above. So square root of, now R and B are these two. So we do 2 minus 0 squared plus 3 minus 0 squared and 4 minus 0 squared. Okay, we do that. That's root, what's that? 4 plus 9 plus 16, which equals root 29. I guess you could technically leave it like that, but root 29 is about 5.39. Okay, next, find the height RQ. Well, RQ is simply this vertical distance here, and recall going from here to here. It's the same as going from the origin to F, and that's 4 units up on the z-axis. So that means RQ equals just 4. Okay. Now the angle between the diagonals BR, which is given, and BQ. We want to get the angle between those two. Well, let's draw that triangle. Okay. So this is triangle. This is a right angle triangle at point Q. It's right angle. That's R and that's B. That's this triangle in here. And we know this one here. We just saw that this is 4. And in part B, we calculated this is root 29, or about 5.39. So you can work out the angle here. Okay, we can use opposite over hypotenuse, which is sine. So sine of the angle QBR equals opposite over hypotenuse. You can use exactly root 29 or copy and paste the decimal version into your calculator. So that means QBR equals arcsine of 4 over root 29. Okay, now if you type that into your calculator, you should get approximately 48.0 rounded to 3 significant figures. Okay. In the next question, it asks you to find this angle here between these two lines. I think all that's given is these measurements here. So let me draw triangle FBD with the theta in there. Now we do know the opposite side is going to be 4. So we know one side, but we're going to have to do some calculations to get BD. Okay, BD is down here on the bottom rectangle. So we can actually draw triangle ABD. There's a right angle here at A, and this is 4, and this is 12. So we can figure out BD using Pythagorean theorem. Okay, so we have BD squared equals 4 squared plus 12 squared. And no need to actually calculate those. You can type this directly into your calculator. Let's check it out. Actually, I think that's going to be an exact whole number. It's going to give you 13. If it's a decimal, you're going to have to copy and paste it into the next question. And so this is 13. So I'm going to use tangent again because we have opposite over adjacent. So tan theta equals 4 over 13. Theta equals arctan 4 over 13. And that gives you rounded that to 3 significant figures 17.1 degrees.